28. Predict by what modes of spontaneous radioactive decay each of the following unstable isotopes might proceed. And then we have fluorine, number 18. Ooh, love it when something rhymes. Okay, anyway, great way to start the video. But we will proceed with fluorine, number 18. I can't. Okay, anyway, so this isotope that they gave us, right, this nuclide that they gave us, fluorine, number 18, is unstable, right? And more so that this is so unstable that it's radioactive. So what's going to happen is this isotope is not going to be not going to want to be radioactive for long. It's going to want to turn into its stable form. So it's going to release some type of particle in order to become stable. But we have to figure out what type of decay mode or what type of particle it's going to release. Whether it's a beta emission or a positron emission, maybe it's going to capture an electron, or it's going to go alpha emission. So the first thing is always rule out alpha emission by looking at the atomic number, right? Atomic numbers greater than 83 are going to be going under alpha emission, or they're just going to be releasing alpha particles, which are just helium, into the atmosphere. But fluorine, right, if we look on the periodic table for the atomic number, because remember, the top number is always going to be the mass number. So they gave us the mass number because that can change for the isotope, but the atomic number is never going to change. So fluorine on the periodic table is number 9. Now, we're clearly not, higher than 83, so we can rule out alpha emission. But now the thing is, well, what's going to happen? Beta emission, positron emission, or electron transfer, or electron capture? And that comes from knowing your NP ratios. NP stands for neutron to proton, whether your ratio is high or whether it's a low ratio. But in order to find out this ratio, you would have to find out the total number of neutrons, which is N, and the total number of protons, which is P, divide the two, because that's what a ratio is. But there's an even easier method to doing this, which I'm going to tell you right now. If you have a high N to P ratio, high goes with high. High ratios means that your mass number is a high or a relatively high mass number. On the flip side, if you have a low ratio, this generally means that you have low mass numbers or lower than normal mass number. So the question is, well, how am I going to know whether this 18 as the mass number is going to be low or high? Enter in the periodic table. Periodic table. So on my periodic table of fluorine, they're going to give me an average value for my atomic mass. And on my periodic table, it's pretty clear that it's a 19.00. So this is even giving me a whole number. 19.00 equals 19. That is the fluorine that has the highest abundance in all the fluorines across the land. Fluorine number 19. This is the stable form of fluorine. So now we compare our mass number that they gave us. Fluorine, stable, wants to be 19. The one that they gave us is 18. So in that case, since they gave us an 18, they gave us a low mass number. So now we know that if we have a low mass number, our N to B ratio is low, and if it's too low, it has to be brought back up. And in order to do that, you can either go to methods. We can either go positron emission, which is the beta plus. So positron emission, or we can take in an electron. Electron capture. Either way would be the correct answer. Now, would we actually know which one this fluorine is going to do? Not really. It's really hard to determine whether something's going to go positron emission or electron transfer because they do the same thing. They bring up the NP ratio. But the one that has the lower activation energy is the one that's going to be done. But for our case and purposes, it's going to be both of them. So that's it. What'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out a little bit more. You could also become a member if you want to be a super fan. No super fan, right? I mean, I just dropped my pen, but that's okay. There's 4 different tiers as far as memberships. If you want to become a member, there's just different perks that we give you a little bit extra. So just check it out. Anyway, I hope you're having a great day, and I'll talk to you soon. Okay, bye-bye.